If you are making a video, building a voice assistant, or an automated content tool, you already know the painful truth. Premium text-to-speech APIs get incredibly expensive at scale. Paying around $20 per month for a limited number of tokens or credits is not good if you are just beginning to create videos or your app handles heavy traffic. But you don't have to pay a single cent. This is a production-ready, asynchronous text-to-speech API running locally. It uses Microsoft's incredibly high-quality Edge-TTS engine under the hood, wrapped entirely in a high-performance FastAPI framework. It is completely free, runs with 0 API keys, and today I'm going to show you exactly how to build it. Now, you might ask, why can't I just use the raw Python library directly in my script? You can, if you're just running a basic local script. But the moment you want to generate audio files from anywhere, you need a robust gateway running from an app on a server. By wrapping this engine inside FastAPI, we gain 3 massive advantages. First, asynchronous execution. Python's asyncio allows our API to handle hundreds of concurrent requests without blocking the event loop while waiting for audio files to render. Second, streaming responses. We don't have to wait for the entire audio file to finish generating before sending it to the user. We can stream chunks of the audio data back to the client in real time, crushing latency. And third, a clean, self-documenting interface that acts exactly like premium cloud endpoints. Let's jump into the code. Let's start with our core dependencies. Beyond basic FastAPI, the magic happens inside the Edge-TTS library, which communicates directly with Microsoft's underlying read-aloud communication channels. To keep our API clean and predictable, we define a strict request schema. We require the incoming payload to specify the text string and allow optional parameters for the voice model, audio file name, and type. Now for the main event handler. Notice that this function is explicitly declared as an asynchronous function. Inside this, we instantiate the Edge-TTS communicate class with 2 parameters, text and voice. Then we wait for it to respond and save the response as the given file name and extension. In the near future, as an improvement, instead of saving this audio file directly to the server's hard drive, which would create storage and performance bottlenecks, I plan to capture the streaming output as a buffer. I can then pipe that data directly into FastAPI's native streaming response, setting the media header type precisely to audio MPEG. The client receives a raw, live audio stream instantly, exactly how premium APIs operate. Now, to run this app locally after cloning the repository, we should follow the README file. Make sure you have Python 3.10 or higher installed. Open your terminal inside VS Code. Create and activate a virtual environment. Pip install requirements. Start the local development server using FastAPI dev. It's that simple, and now it's working. Let's test it out to see if it generates audio files. It successfully created our test file. The complete source code for this entire FastAPI wrapper is completely open source and available right now on my GitHub. I have left the link in the description below. If you are sick of paying huge amounts of premium cloud bills for text-to-speech processing, clone this repo, run it locally, or throw it onto your private server and spin it up. If this app helped you save on your costs, drop a star on the GitHub repository and hit the subscribe button. Let me know in the comments what specific features or integrations you want to see built into this API next. See you in the next one.